Today, we are diving deep into NVIDIA's brand new Vera Rubin platform. Now, they're calling this the architecture for the next generation of AI, and it's not just another chip. Unveiled back at CES 2026, this is a whole new way of thinking about how we power artificial intelligence. So, what's the big problem it's trying to solve?
Well, it's this question. This is the question that the entire industry is trying to figure out right now. You see, we're moving past AI that just predicts the next word in a sentence. The real goal, the next frontier, is an AI that can actually understand what you want, break it down into steps, and then go and execute that plan all by itself. And the amount of sheer computational power you need for that kind of reasoning, it's just staggering.
And that really gets to the heart of AI's next big challenge. To get to this new level of intelligence, you can't just make the old designs a little bit faster. The problem itself is so different that it demands a totally new kind of architecture, one that's built from the ground up for this one specific purpose.
And there's a name for this, you know? It's called Agentic AI. The best way to think about it is like the difference between a simple calculator and a true personal assistant. A calculator just answers a single prompt, but an assistant, it understands your larger goal and takes a whole bunch of different actions to make it happen. That massive leap in reasoning and planning is exactly why we need a hardware revolution.
So, how is NVIDIA taking on this massive challenge? Well, their answer isn't just one single chip, but a whole, fully integrated system. It's a concept they've nicknamed the AI Factory.
And this right here is the big idea behind the Vera Rubin platform. Instead of just giving us a faster GPU, NVIDIA has designed an entire data center rack where every single part is built to work together in perfect sync. It's a complete system, a literal supercomputer in a box. And it's designed to do one thing and one thing only: power agentic AI.
Now, Vera Rubin didn't just appear out of thin air. It's the next logical, massive jump after the Hopper and Blackwell architectures that so many people are already using. It was officially launched at CES 2026, and it's already in production, set to start shipping to the big customers in the second half of this year.
Okay, so what's actually inside this AI factory? Let's pull back the curtain and break down the different parts to see how they all work together. What's so cool about this is how these 6 different pieces were designed together to get rid of any bottlenecks. So think of the Vera CPU as the project manager, or the conductor of the orchestra. It handles all the complex reasoning tasks. The Rubin GPU, that's the engine, the powerhouse doing all the heavy lifting. Connecting them is the NVLink 6, which is basically a data superhighway. And then you have these specialists, like the Rubin CPX, which is built for these crazy massive context jobs, plus all the advanced networking to feed data to the whole system. And it's all tied together with this insanely fast HBM4 memory, which makes sure no part of this system is ever just sitting around waiting for data.
So you get all this integrated hardware working in harmony. What does that actually mean for performance? Well, the gains here aren't just a small step up. They're a massive, massive generational leap.
First, and this is a big one, a 10 times reduction in the cost of inference. Inference is just the cost of running an AI model after it's trained. Making that 10 times cheaper is what will make this sophisticated agentic AI actually affordable for people to use every day. It moves it from being a research project into a real-world tool.
Second, it's 4 times more efficient at training new models. Now, what this means is that a company might only need a quarter of the GPUs to train the same cutting-edge models compared to the last generation. That just completely lowers the barrier to entry for building the next big thing in AI.
And third, there's the raw power. The Vera Rubin platform delivers up to 5 times the raw throughput. This is just sheer computational muscle that lets these models process way more information way faster. And that unlocks a whole new level of complex problem solving.
And this chart just lays it out perfectly, doesn't it? It shows that 5x jump. We're not talking about a little 10 or 20% increase. Going from the Blackwell generation to Vera Rubin is a monumental leap in raw compute power, especially for the kind of math that AI inference depends on.
Okay, so that's the tech, and those are the mind-boggling numbers. But what does this mean in the real world? Who actually gets to use this stuff, and how?
Well, it really depends on who you are. For the huge cloud companies and the big AI research labs, this is a total game changer. It lets them train even bigger models more efficiently and run them for a fraction of what it used to cost. But for you, me, individual developers, or smaller companies, you're not going to be buying a Vera Rubin rack for your office. It's complete overkill. Instead, you'll get access to this power through the cloud, and the benefit you see will really depend on how the cloud providers decide to price these new, super powerful instances.
And look, this is not some far-off, futuristic technology. The biggest names in the game are already lining up. Companies like Microsoft, OpenAI, Amazon Web Services, and CoreWeave, they are all at the front of the line to get these new AI superfactories, which tells you a massive industry shift is already happening.
And to really get your head around the scale of this thing, just listen to this quote from NVIDIA. They said that the internal data bandwidth of a single one of these racks is greater than the traffic of the entire public internet. I mean, that's an almost impossible amount of data to imagine, all focused on a single task.
And that really leaves us with the biggest question of all. This platform, it isn't just an upgrade. It's a key that unlocks a whole new class of AI. So when you give the smartest researchers and engineers a tool that can compute at this kind of unbelievable scale and speed, what happens? What problems that we thought were impossible, from discovering new drugs to creating new materials, will we finally be able to solve?